Okay, so it won't be here tomorrow. So bring your earbuds. If I make it, what I'll do, let me grab this. Anyone not here Tuesday? Anyone? Right? Michaela better be doing something. And did you print this, or I get this to you yesterday? No. Okay, pass this back. Please, thank you. Pass this back. What you got there? A little snack during class? We're just pulling out snacks in the middle of class. Close that up and put it back in your bag. Yesterday, I pulled it right out of someone's hand that touched their actual snack and ruined it. Yes. Well, yeah, no eating. Where she's allergic, and then a crumb hits her, and then she explodes. All right. Anyone ever see Jumanji? How is cake my weakness? Anyone? No one saw the original Jumanji? Right. Sorry. Anyway. Okay. So this is 7. Oh, I actually had that on tape. Sorry about that. But anyway, you're going to be missing yesterday, so be aware that I might have an ed puzzle for you. Does anyone remember ed puzzles? It's instead of like just doing a YouTube video and and I got bums that don't do homework. We know that, right? All right, and we don't do the work that I ask you to do. Doing an ed puzzle actually makes you pay attention, makes you answer a question every once in a while. And those that get a 1 out of 8, I know they're just clicking buttons and couldn't care less about watching the video. So it actually tells me a lot about that. But the ed puzzle will be maybe some questions on it, but what it will be, and this is why I started class by giving this out, is the back of the sheet. Okay, just kind of synthesizing all the formulas. They don't hit every single one, but the general idea, I expect you to watch it, right? And maybe an example or two. I'll see. I got to make it today. So look on your Google Classroom. I'm not sure I've done an ed puzzle this year. I don't think I have I? So you may not even be in a class yet. So I think I have to invite you to the ed puzzle class, and then the ed puzzle assignment will be on there. And then after that, I think I have an idea what I want to give you for a worksheet. You just took a second worksheet today. The second one, do not, and it doesn't ask you to, do not draw the nets. Okay, just calculate. I made the worksheet in like 2 minutes. I picked 6 surface areas, 6 lateral areas, reverse that, the order, and then 6 volumes. That's what today's thing is. Okay, so that just give you an idea. So I guess what I'm saying is bring your earbuds. All right, so that's 7. I'm going to go over here, though, because what I really need is this. I need the perimeter, all right, for our surface area. So I need, to get that taken care of, because the area of these are half apothem times perimeter. And yes, hey, by the way, I asked Lexi Samuelis yesterday. Nobody cares. I don't care. Wait, what are you doing in math? I haven't seen your work come home lately, because I had to help Brianna, who's a junior. She's doing conic sections right now, huh? Ellipses, kind of cool. So I get to help her with that stuff. But I asked Lexi, the 6th grader, and she goes, "We're doing volume." I almost fell on the floor. I'm like, it's a 6th grade concept that she's doing that stuff. So why are we doing it now? Because now we can incorporate the math that we know. Lexi doesn't know how to do this. She doesn't know how to find the perimeter with just the apothem given. So she's got to do something different. I'm sure she's doing real basic. She's probably just doing rectangular prisms, length times width times height. So, but we got to remember that this is 30 degrees. And then I'll throw some things at you that you should also remember. This is 60. Kind of hard to write that. The reason I know that's also 60 there is this is all 120. And where that comes from, reminder, there's a couple different ways I could get this to be 30 and that to be 60. This is 120 because there's 6 sides, 6 angles, and it's from this formula, 6 minus 2 times 180, but then divided by 6. So that's why I know that's 120. So we could have done it that way. Or another way is that a full circle is 360. So this angle measure is 60. 360 divided by 6. And then when I drop the apothem, that's cut in half. So again, reminders from the previous chapter, if we want to call it that, even though these are kind of really connected. So with that being the case, what side is 7? Let's say this as a group response. Is it A root 3, or 2A? 3, 2, 1, go. It's a root 3. So the big problem with this is it's the a root 3 side, and it's 7. So I got to set those two equal and solve for a, because a is the 30-degree side, and that's ultimately what I need. So that's the rub on this. That's the not grade school concept. This is adding what we know, to the concept. And then we know what 7 over root 3 is. That's 7 root 3 over 3. That means this side is double that. Then we might think, oh boy, that's going to be a mess. It's not, as a matter of fact. And now we can do lateral area, because guess what? That's 14 root 3 over 3 as well. And then this is 8. So now for lateral area, we can go ahead and do that. I have 6 rectangles. So again, I made you draw the nets yesterday on the homework, just because, to simplify it, I have 6 rectangles that are length times width. That always happens for a prism. So length times width is 8 times 14 root 3 over 3. That 14, that was not the pen, that was me. I kind of pulled the pen away too quick. 3 goes into 8. I'm sorry, 3 goes into 6 twice. I guess I do have to get a calculator. 2 times 8 is 16. I don't really know 16 times 14. What do I do with the calculator? Anyone got it? No one usually helps me in here as they wander around. Okay, so 3 goes to 6, 2 times 8, 16. I got it. 16 times 14, right? 224. So this is 224 root 3. And then I didn't give units, so let's say units squared. Then let's, for those that highlight, understand lateral area is just those rectangles, right? So that's why I separated all the, 6, 6, and 6 lateral area, then full surface area, and then at the end volume, which is actually really easy. I doubt Lexi's doing lateral area and surface area. These can get quite involved for a 6th grader. All right, and then what we have to do is add that for total surface area. Oh boy, that's the first time I saw my pen do a little pickup there. So that plus 2. Now I'm going to write it like that. We have 2 of these hexagons. So now that I have the apothem, actually I was given the apothem, half apothem times perimeter, which is 6, 14 root 3 over 3s. Actually, 6 goes into 3 twice. 2 times 14 is 28. So that is the perimeter of each of those hexagons, and I have 2 of those. Okay, so half of 2 is 1, so it's just 7 times 28 that I have to handle. 7 times 28. That's 196 plus 224. That is that right? I don't think I got that last time. Is that 420 root 3? Did anyone else do that? I feel like I did that wrong. So 7 is the apothem. Perimeter is 6, 14 root 3. 6 goes to 2. 2 times 24 is 28. So it really is 7 times 28, 196 root 3. Okay, 420 root 3 units squared. I feel like I didn't get that last hour. Okay, then pyramid, I'm going to cheat. I'm going to go to this thing right here and just talk about what a pyramid is. Okay, and it's very simple in order to do this. A pyramid is, by definition, just one base. And then remember from our constructions, which I can, in the video, can actually do this. For a prism, let's take this hexagonal prism right here. Where's the video there? The lateral area, that's a bunch of rectangles or squares. Almost looks like squares on this one, but rectangles at least. For any pyramid, the faces are all triangles. We could see that. We actually saw that with the nets. So actually, that is why the formula for finding the lateral area is going to be really easy. You actually don't even need a formula. You basically need to just add the area of the triangles, right, if you draw the net out. So a regular pyramid is all that we're dealing with. I think they're called maybe oblique pyramids when they're slanted. I think I might have that wrong, though. Those are some things we could talk about maybe Monday. when they're slanted, how do you find the area, or maybe the volume? It's not really that hard. But for a regular pyramid, the base is a regular polygon, and we're straight up and down for the height. And the faces are all equal triangles or congruent. Right, very simple there. Okay, going back to this. All right, and then this program got mad at me because I went to another program and then it throws a little fit. All right. So here's why this is what it is. And again, I probably should have had these blanked out and have you put these in, and then the fact of writing, you do all right. But the lateral area is this formula, but it's really easy to derive this formula. Why is it half perimeter of the base times this L, which is the slant heights? Well, actually, I can prove this through drawing the net, and I want you to do that for this one. So drawing the net, it may not be able to be equal in size as far as that square is concerned. But this is what you had, and we actually had to put together a square pyramid. For those that had a square pyramid, this was what the net looked like. Triangle, 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 and triangle. So if you understand that lateral area, it's just the area of all of these triangles. Very simple, all right? And then that's what I have to do. I got to find the lateral area here. I'm also going to find the total surface area, which is just adding the area of the base. Okay, but I might have to pull this off to the side. So I have 12 here. That means this is 6. So what I need is what's called the slant height. I need this. This is the letter L. If you look up there, L is used for the term slant height. I don't know why. You just got to do it and understand that. But what we got to understand why that is what we're finding, because that is the height of each of these individual triangles. So that is actually L right there. So it's just the height of the triangles. You really don't need this formula. All you got to do is draw the net, find what this is, and then know what that base is, and then do half base times height 4 times, right? Okay, it's pretty simple. But anyway, we'll stick with the formula, and then I'll pull this triangle off to the side over here, where this is L again, right? And I'll stick with that letter L. I think last hour I made that X when I pulled this off to the side. But just to keep you involved here, 6, and then this is 15, the actual heights. So what we got to do is, what theorem? I had his shirt on yesterday. 3, 2, 1, go. Pythagorean. Pythagoras fighting with, what's the other guy's name? Einstein. Has he even noticed my shirts anymore? I kind of have to recycle them. I figured out, how many days do we have in a year? If we have 9 weeks, 9, 18, 27, 36. We have 36 Wednesdays. I don't have 36 math shirts. So I do have to re-wear some of those. I think I've used that one quite a few times. Okay. No one's really listening, so be quiet, Mr. Samuels. 6 squared. Okay, so I get 261 as this sum here. Hey, everybody, what's 2 plus 6 plus 1? Just answer the question. 3, 2, 1, go. 9. These digits add up to 9. So what is this number divisible by? 9. So I divide by 9, and I get 29. What's the square root of 9? 3 root 29. Remember that little section we had on simplifying radicals? All right. All right, so we got that. So this is 12 all the way across, and then this now equals 3 root 29. That is why the lateral area, LA, equals, we could write this as 1/2 12 times 3 root 29 times 4. But that's what this formula does. 1/2 the perimeter, which is 12 plus 12, 24, 48. That's the 4 triangles bases times the height. It's the same thing. Okay? Same thing as taking half base times height for every triangle, then multiplying by 4. Really is the same thing. Okay, so that's what I want you to understand. Half of 48 is 24. 24 times 3, 20, 40, 60, 72 root 29, I believe. Right? Isn't that right? Anyone double checking here? And I did have feet, so this is feet squared. Okay, so I color that in yellow if you're doing highlights. And I stopped on 29 because 29 is prime. So square root of 29 doesn't break out. And then for the area of the whole surface, so I will do that even though it doesn't say so. Surface area is 72 root 29 plus 12 times 12, which is 144. Not like terms, cannot be added. So that's good. You don't have to do anything but write it if they ask you to do it in exact. Okay? So ain't no thing, chicken wing. Cones, really not a big deal. Gonna be super lazy again with the words. Cones are a pyramid-like base, or it looks like a pyramid, and the pyramid is like the base is a circle, right? That's kind of bad words. It's pyramid-like, comma, the base is a circle though. So actually it's going to be the same formula, but it's going to look a little different. Again, the word altitude means actual heights. Vertex is the top. Slant height is that drawing right there, that red line there. Okay, so it's really not that big of a deal. A cone is very much pyramid-like. Unfortunately, I didn't have any cones. I should have looked up a cone. It wasn't in that printout that I had. I should have had you put together a cone as well. So we do have that. I do want to share some things that you should know. Okay, for instance, what's 36? A diameter or a radius, the way that's drawn there. 3, 2, 1, go. Diameter. So you better know that this is 18 for a radius. Now, you're ready for this? Because this is what an honor student should be able to do. They should be able to remember a lot of stuff. Like how many times does 6 go into 18? 3, 2, 1, go. 3. How many times does 6 go into 24? 4. 3, 4. Anyone? 3, 2, 1, go. 5. Everyone should know 3, 4, 5 is a Pythagorean triple and any multiples of that. So what is the slant height? 3, 2, 1, go. 30. 6 times 5. This is 6 times 3. This is 6 times 4. 6 times 5 because of a family of 3, 4, 5 Pythagorean triples. So as an honor student, you should also know 5. Anyone know the next one? 3, 2, 1, go. Not 6. Not 7. Not 8. Let's keep going. Not 9. Not 11. You're getting closer. 12. So then 5, 12. What's next? 13. That was fun. This will also be fun. 8. Anyone? Let's not say 9. 8. There is a 17. 15, 17. Now go ahead and check these. You can do 8 squared plus 15 squared. Press enter. Then do 17 squared. I think those are the 289s. So 8 squared plus 15 squared is 289. 17 squared is 289. Then there's one more. 7. Anyone? This is in the 20s now. Nope. 23 is close. Michael Jordan. 24. Anyone know the last one? Oh, 25. So that's funny. What's 25 squared, by the way? 3, 2, 1, go. Oh, no one knows 25 squared? No, that's a square root. You reversed it. No one knows 25 squared? You can just take that as a calculator, cheater. All right? 625. You don't know your squares? What's 20 squared? No one else answer. What's 20 squared? Eyes are locked on. What's 2 times 2? 400. You got it. So everyone should know 20 squared, 30 squared, 40 squared, 50 squared. I think you should know 25 squared. You should know up to 15. What's 15 squared, everybody? 225. 14 squared? 190. You should know what it ends in. It ends at a 6 because of 4 times 4. What's 13 squared? What should 13 squared end in? What number? A 9. And it's 169. Right? And then you should know 12 squared, of course. You should know up to 15, and then 20, 25, and then 30, 40, 50, 60, all the way up. Are you okay? So you're okay. All righty then. Hey, draw this. That in that little section right there is the net of a cone. Now, because I'm missing tomorrow, I would have stopped probably after this one. But because I'm missing tomorrow, I'm going to keep going and do volume with you. All right? Would have probably stopped and taken a breath. But then I told you what I'm going to do with that Ed puzzle just to see that you did something. Maybe I'll try to get that. Well, I'll have to get it done before I leave today. So I'll open up the Ed puzzle even today. So you could even do it tonight if you wanted. I definitely have a worksheet. I already know what I'm going to print. I stole something off the internet again. I think I told you. And I'm going to print that for you to work on tomorrow. It's only on volume. Some special little questions. All right, but that's the net. And actually, I found something interesting, and I may investigate this with you next week. I love deriving these formulas. I love knowing where they come from. I love sharing with you that the distance formula between 2 points on a coordinate plane is actually the Pythagorean theorem. And actually, in the last test, I had someone draw. There was the 2 dots, and they had to find the distance. They actually drew the triangle, put those lengths there of that triangle, and did the Pythagorean theorem. Genius. All right, and that's why that makes it simple. You always have a way around a question if you don't remember the formula, right? And that's why I like this. But you look at what I put, and I stole this off the internet, big thief. But that's actually a sector. And hopefully you can conceptualize this, that this is, if I cut it, a cone. If I cut this until right here and I stopped, and then here, if this was a piece of paper, then I'd wrap this and connect these 2 sides, and lo and behold, this would be a circular top for this to lay right on top of it. So actually, what this is right here is the circumference of this circle, right? Correct? And then this is the slant height, which we will put that as an L. Okay, so again, looking at that cone, that is this side, like right here. You know, if I kind of compare these, if this was then equal to that. This is what blew my mind. And then maybe I can investigate this on Monday or whatever, because we do have a lot of extra time. So it's cool to kind of look at these things. I found out, you already know area of a sector is whatever this angle measure is, which we can't know. It's not related to what the size of the circle is. Well, there's a relationship, but it'd be hard to find. But area of the sector, do you remember, is this angle measure divided by 360 times pi r squared. Pi r squared is the area of a full circle. This angle divided by 360 is that fractional part of that area, right? Do you remember that? Hello? Well, then I come to find out that another area of a sector is actually this radius of this sector times this arc length. And I'm going to prove that next week. I think it's kind of fun to look at that. So I just wanted to share that because the formula is exactly the same. Half perimeter, but what's perimeter called for a circle? It starts with a C. 3, 2, 1, go. Circumference. So if you remember, lateral area for pyramids and cones is half perimeter times slant height. All you need to know is the perimeter of a circle is circumference. That's what 2 pi r stands for there. And then L ends up being, the slant height letter. Because you're going to have to memorize this. That's why I'm going over this. All right? There is no, 2 ways about it. That is a thing. And then to get the full surface area, you just got to add the area of the circle to the lateral area. So that's very simple. Alrighty then. Okay, so we won't go backwards to that one. We'll find the lateral and surface area for that. Hey, I just covered this. So that's a diameter. So what's this? What's this length from here to here? 3, 2, 1, go. And then I just covered this. What's this length right here? 3, 2, 1, go. This is a 5, 12, 13. I shouldn't have to write out the Pythagorean theorem if you don't memorize that. 5 squared plus 12 squared equals x squared. Solve for x, you'll get 13. Okay, honors. I don't have to do everything here. Some people expect me to write every single thing down because we don't remember stuff that we're supposed to be remembering. Okay, so then lateral area is half perimeter times slant height, which is half. Perimeter is circumference, and it's circumference of the circle it's attached to. So it's 2 pi r. I had to keep looking at that. And then times the slant height, 13. Okay, actually, I could do this one. Half of 2 is 1, so they cancel. 12 times 12 is 144. Add another 12. That's 13 12s. It's 144, 154, 156. Is that right? Pi. And then this is inches squared. Then all I got to do is add that to, okay, it's kind of hard to highlight. I can't highlight lateral area unless I did the net. So I can't highlight that in yellow on the picture. And I don't feel like drawing the net. 156 pi plus pi r squared. And then I think 156 plus 144 is 300. And then it's inches squared. Okay? All right, and I think that's if I was going to be here tomorrow, I may have stopped and said, all right, go ahead and work on your stuff. Now, you'll have work time tomorrow. We'll see how long that ed puzzle needs. I just want you to do something, not a big deal. Okay, so going to be lazy here. I'll go ahead and show you my written notes on my old, back in the days at Lewis. Okay, so volume, we're going to proceed on because volume is actually really easy. Actually, it's way easier, and that's why Lexi's probably doing it in 6th grade. But still, Lexi would not be able to do the things that we're doing, like hexagonal prisms and hexagonal pyramids and memorizing the formulas. So it is ratcheted up a little bit. But really, it's a simple formula. But to understand what volume is, it's a 3D space inside. And then I actually wrote this over here. That's why we have to do units cubed, because the number of units cubed is the number of these blocks, 1 by 1 by 1 blocks that fit inside the object. So that's why we need units cubed, right? And I thought I'd draw that in there and conceptualize that. Remember I did that with area? Those in the front row, for my PowerPoint, I had the squares and showed you that a rectangle that's 3 by 7 is 21 units squared because 21 squares fit inside that object. Well, now it's cubes, 3-dimensional objects that fit inside. Here's the difference between you and Lexi. I doubt she's doing square prisms, hexagonal prisms, trapezoidal prisms, and she's certainly not having to do 30, 60, 90s to find missing parts. So that's where the difference is. We have that latitude to ratchet this up a little bit. Remind you of some grade school formulas, but then I'd like to say algebra to it, although that class doesn't exist at good old Lockport's. Okay, so find the volume of the prism, blah, blah, blah. There's those written out words. It's really just volume equals big B times H. Now, I know you did, and this is what Lexi's probably doing. It's really length times width times height is what you learned back in the day. But isn't length times width the area of the base, right? So it's the same thing, and we want to keep this the same so that we can memorize the formula, which it's done. Big B times H, we just got to know what big B is. So this is 12 cubed, 12 times 12 times 12, and then it's inches cubed. Okay, and then whatever 12 cubed is, you can calculate. I'm bored. Okay, by the way, I don't need it, but 8, 15, say it. 3, 2, 1, go. 17, don't write it, though, because it's not needed in this. Luckily, this is a right triangle. Otherwise, it would be an Algebra 2 question. How could I get the area of that triangle? What other information would I need to find? So again, I could do that. That's what you got to be ready for. But since it's a right triangle, that is the base, that is the height. So this one is 1/2 base times height. That's the area of a triangle times the height of the actual prism itself, which happens to be that other 8 randomly. All right. And then, I don't know, I guess I should write some of these answers down. So 4 times 8 times 15 is 480 oops, 480, and then we'll do inches or meters cubed. Okay, don't know if I have many more of these. Okay, well, cylinder, it's really the same, and I guess I could do both of these. It doesn't really matter. But really what a cylinder is a prism where the circles are the bases. So it's the same stinking formula. Volume equals big B times H. What is the base? Well, it's a circle, so it's pi r squared. And then times 6, the height. Just know that the height, even though it's laying on the ground, the height is the connector of the circles. I guess I could do that one. 3 squared is 9. 9 times 6 is 54. Pi. Don't forget the pi or else I'll get you. And meters cubed. Did I put cubed on the last one? Good. All right. So meters cubed on that one in terms of pi. Or exact would be the other way to say that. Okay? I'm not going too fast, am I? Brianna's notes weren't very good yesterday on ellipses. She goes, well, the teacher goes fast, but she had like nothing. We had to do completing the square. She had no notes on completing the square. I'm like, what are you doing? Remember completing the square, right? Getting them in standard form. So I had to go through, take half the middle term. Anyone? Then what? No, yeah, that's a divide by 2. Then what though? Square it. All right, so we had to go through that yesterday. Okay, we know that's a diameter, so this is 11 halves, and I kept it as 11 halves. So volume again, big B times H. What time do we got there? We're fine. Volume equals 11 halves squared times pi. And then that's times 16, the height of the actual thing. Now, this drives me nuts with my seniors all the time. What's 11 halves squared? What's 11 squared, everybody? 3, 2, 1, go. What's 2 squared, everybody? 3, 2, 1, go. It just baffles me, seniors, that cannot square numbers, right? Square fractions. It's infuriating, actually. Makes me sad. Then I was telling Brianna, don't touch your calculator. Listen, what's 4 times 100? 3, 2, 1, go. 400. What's 4 times 20? 3, 2, 1, go. What's 4 times 20? 3, 2, 1, go. 80. Then what's 4 times 1? Add them all together. That's 484. Right? 400 plus 80 plus 4. Practicing mental math makes you numerate, not innumerate. Being able to deal with numbers. Okay, and then I'm not proving this, but I am going to draw this. You have to understand, and let me try to do this better than the other class, how to draw a prism. You basically draw a square, and then a square in your mind conceptually above it. I guess I would see all these, and then connect them. Don't do this. What I'm trying to do is make a point, though. I didn't go too far in that one. Don't you agree that the volume of that prism is way bigger than the volume of that pyramid? Yes or no, right? So it can't be big B times H. It's got to be something smaller. The only thing you got to remember is 1/3. Did you hear what I just said there? Right? So it is big B times H, but it's not the same as a prism. It's smaller. The fraction is 1/3 of that. All right? So that is something you're going to have to remember. What's that fraction? What's for volume of pyramids and cones? 1/3 big B times H. And then I don't think I have to go crazy with this one. I don't need the slant height on this one. I hit that red. Volume is no deriving the 1/3 where that comes from. I don't think I've ever done that and known the reason why. It just is sometimes. And then big B is 12 times 12. And then height is 15. I was trying to find myself there. And then whatever you get out of that. I think I calculated that last hour. I'm bored right now. All right. This one, this is a good one. I have the slant height, but I need for volume the actual height. So I got to draw this triangle. And then I got to find this H right here. So this is certainly, for this to be the height, that is a right angle. So again, it's the Pythagorean theorem. This one I will write out. So to find that height, it's 8 squared plus 4 squared, and we are going to get a decimal on this one. Okay, getting to it real quick. 7.2 squared minus 4 squared is what eventually is going to happen. And then that's 35.84, but then you got to square root that. This is all stuff we should know. I actually get h is 5.99 if I round to the 100th. You really shouldn't round to the end, so you should use this all the way out decimal and plug that into our volume formula, 1/3 big B, which is 8 times 8. It's a square pyramid. I guess I should have marked this. This is improperly marked, by the way. So we probably should have marked this as all 8s all the way around, so you know it's a square. You really can't assume, but you know it is. All right, 1/3 big B times this 5 point, and I'm going to write this like this: 5.986 ... because you just typed it on your calculator. So just hit save that number and then multiply it in this. This one has to be a decimal. You can't put it in exact because of that 7.2. All right. Well, I mean, there is a way, but it's kind of annoying. I'll just pick one of these two. Who cares? Let's just do this one. Oh, this one actually is fun. Okay, so I have to do the same thing again on this one. I need that. I need the heights. So this is 21 here as well. So it's a Pythagorean theorem again. I guess this one I can do exact since there's no decimal there. The last one, technically, I could do exact, but it's a pain, that annoying decimal. So if any true mathematicians listening to me out there, I get that. I'm just not going to do it. This one I will, though. So 21 squared. I wonder if this will be breakdown at all. Minus 12 squared. Enter. 297. Oh, my goodness. What's 2 plus 7? Answer. 3, 2, 1, go. And then 9 plus 9. 18. So the sum of those digits add up to 18. So what's it divisible by again? 3, 2, 1, go. 9. So I'm going to divide 297 by 9 because it is the square root. So this ends up being h equals the square root of 297. That's what 21 squared minus 12 squared was. Then I get 33. What's 33? What times what? 3 times 2, 3, 2, 1, go. So 3 times 11, nothing comes out of that. So it's 9 times 33. So this is 3. Weird. 3s are wild. Root 33. So 297 divided by 9 was 33. Square root of 9 is 3. Free out there. So now, what's the volume? 1/3 big B, which is 12 squared times pi, a circle, times that 3 root 33. What an interesting exact answer that we can write on this. So actually, it's just these cancel. That's weird. And it's just 1. I was going to go to the calculator, but I don't. Oops, sorry. 144. Right. I started writing pi too early. It's a brain mishap, not my pen. Pen's working great. Having a good tech day today. Love it. I think that's a good one to end on. The exact where you have both a pi and a root in there. Lexi's saying that certainly is not simplifying the square root of 297. So those are the things that come up here. All right. Like I said, tomorrow I'm going to fill all these in. Remember, you have an area master sheet, too, from last chapter, if we call that. Remember that? All right. I got all the areas on one page. Well, I had to flip over for the last set of areas. So you might want to review those. And that's how we could say this next test we're going to have is sort of cumulative to the last test. So we're good on that. All right, done. How do I get out of this? There we go.